Here's a problem about, well, it's phrased in terms of lists. The technical term is it's really secretly a problem about arithmetic sequences, which we're going to discuss later in the year, but we can do this without a lot of terminology. It says the list consists of 1,000 consecutive even integers. What's the difference between the greatest number in the list and the least number in the list? And it's very easy to get things off by just a little bit in this kind of problem. So this number is really big. Let's just first do a little test case. Let's start with some even integers like 0, 2, 4, 6. Okay. There's 4 integers and it goes up to 6. Or in other words, 2 times 3. Okay. So let's just check this. Let's see. 4 items on the list and it goes up to 6. Okay. Let's just go a little bit further. Let's say 8, 10. Okay. Now we've got 6 items on the list. It goes up to 10, or 2 times 5. And so this was 2 times 3. So every time we add an item to the list, it's going to go up, the highest item on the list is going to go up by 2. And so that makes sense that the maximum item, the greatest, is 2 times something. But it's not 2 times this number, and 10 is not 2 times this number. Okay. So what it looks like is that if there's n items on the list, then it's going to go up to, looks like double, oops, no integral, double of n minus 1. So let's check that. If there was 1 item, it'd just be this guy. Oh yeah, it goes up to 0. If there's 2 items, it goes up to 2. So 2 minus 1 is 1, and 2 times that is 2. Okay. And again, like these guys are other checks on these things. It's a very common thing about listing. You get like n minus 1. The basic example of that is how many numbers are there, just consecutive numbers are there between like 5 and 12. And it's not 12 minus 5. What is it? If they're just consecutive numbers without the even, 5, 6, 7, 8, 9, 10, 11, 12, it's 1, 2, 3, 4, 5, 6, 7, 8. It's not 7. Oops. It's 8. Okay. So when you count things, there's one more thing than you could expect. Or another way to say it is, if you have 6 items, this 6 doesn't go in here. It's really a 5 that goes in here. Okay, so that's a kind of a tricky issue with counting. So now we've got, let's just start with from 0 again. 0, 2, 4, 6. How many things where am I going to have to stop to make exactly 1,000 even integers? Well, this rule tells us we take 2 times 999. It's 1998. And so that should be 1,000 things. Let me say that again in another way. This is another good way to see this. It's really 2 times 0. This is another good way to analyze the problem. Any list of even integers, you can say, oh, it's 2 times something, 2 times something, 2 times 0, 2 times 1, 2 times 2, 2 times 3, 2 times 4, etc., up to 2 times 999. Is that 1,000 things? Yeah. If you started with 1 to 999, that would be 999. Because I started at 0, that's actually 1,000 items in the list. And so the biggest is 1998. And because I started at 0, the smallest is 0. So the answer is 1998. Now, what if I hadn't started at 0? Then this number would be bigger, but this number would be that much bigger, and the difference would be the same. That's why there's a well-defined answer to the problem, regardless of where you start. It doesn't say where you start on this problem. That might freak some people out. They didn't tell me enough information to solve the problem. It doesn't matter. If you start off at 1,000, you're going to go up to 2,998. One thing that I did here throughout was I started counting at 0. Some people like to start counting at 0. Some people like to start counting at 2 for this kind of problem. It's kind of up to you. If you start counting at 2, there's some advantages and disadvantages of that. So that's actually pretty nice for this kind of strategy. 2 times 1, 2 times 2, 2 times 3. Now, to get 1,000 in the list, I do go up to 2 times 1,000, which is 2,000. And that's maybe more intuitive. The thing is, though, then you have to subtract off the 2. The difference between 2002, 2000 minus 2 is 1998. I like starting at 0 because you don't have to subtract anything off. You're just staring at the difference right here. But they're both good ways to do it. Okay, so the main thing is to make sure you're careful about this n plus 1, n minus 1 issue. This idea that like the number of numbers between two things is not their difference. It's off by 1.